All right, so the first question on FRQ 1 is going to ask you to do some kind of composition, and then you're going to be asked to do an inverse, and then you're going to be asked to do when a function equals a certain value, or where's the zero of the function, and then you're going to be asked to give a end behavior as a mathematical limit. That is going to be the same. What's going to change is sometimes one of the functions will either be a table or a graph, and then the other one will be in algebraic form. And so the first thing you're going to do with the one in algebraic form is put it in the calculator. So if you haven't grabbed a calculator yet, sorry, go grab one. Now that equation, this one is a rational function, but it can be any type of function that we've talked about all year, except it will not be a polar function. There is no polar anything on the free response. It will only be on multiple choice. Okay, so like I said, A and B, 1 and 2, each part will pretty much be the same for all of the different possibilities for FRQ1. What is different is part C. So C could possibly ask you to look at the table and decide if the function is linear or quadratic or exponential or logarithmic. So you make that decision. And then part 2 of C will ask you to give a reason why based on the function or something. Now this is where I changed it from what I did in the past and what I'm going to do this year. So we're going to mark some stuff out. But for linear, we are going to say the first differences in output values are a constant. And then you do need to put in the value of the constant. So it'll be 2 or -5 or whatever. That's important. Now, in my first couple years, we had to memorize this craziness. We don't do that anymore. We just talk about what the input values are doing. So you have to give a reason based on the change in output values and the change in input values. So the input values are just going to be increasing by something each time. So you would say something like, while the input values are increasing by blank, whatever, and you need to put in that each time. Now before I graded FRQ1, I didn't realize that you had to put that number in there to get your point. So it's really important that we do that. All right, what is going to be a constant for quadratic? Do y'all remember? Second difference is good. So it is important you say the second difference is in output values are a constant, and then you need to make sure you tell them what that constant is, while, and the input values are going to be doing the same thing. Okay. Do you remember what's happening with the output values on exponential? output values are being multiplied by something each time. So the output values are being multiplied by something each time, while, and that input values is the same thing we just wrote twice. So who remembers logarithmic? The input values are being multiplied and the output values are increasing. So it helps if you remember exponential and logarithmic are inverses. So basically input and output are going to switch. So you would say the input values are being multiplied by something. And then the output values are increasing by a certain amount each time. So there is a lot of writing, but if you just tell them what you noticed about input and output, you'll get that point right. Don't try to be fancy. Just say what's happening, how those input and outputs are changing. And it doesn't matter what order you write it. Sometimes I'll switch up. I don't know why I do that. Sometimes I'll start with input, sometimes start with output. I don't know. It really doesn't matter. All right, and then the other question it could ask is determine if F is invertible. So the first year we had this class, I guess it was 2024, the question on the free response one was the invertible question. And then last year, 2025, it was, pretty sure it was an exponential function. So it could switch back. I don't know. It's just a guess. I know it'll be one of these two for sure. And so it's possible that C is going to ask if it's invertible. And then if you're looking at a graph, how can you tell if a graph is invertible? Just by looking at it. The horizontal line test. So if it passes the horizontal line test, the function is invertible. If it doesn't, then it's not invertible. And then a table, you just make sure that the y's don't repeat a value. But that cannot be your reason. So the reason for invertible is each output value of F is mapped from a unique input value. So that's what you say if you answer yes to determine if F is invertible. And then you have a little bit more to write if it's not invertible. So if you say no, then you say something like some output values of F are not mapped from a unique input value. And you have to give an example. So I just made one up. So it would have to go along with your function, but for example, f of 2 equals 3 and f of 5 equals 3. So if you don't give an example on that, you don't get your point. All right, y'all ready to do a problem? Forgot the order I did this in. There we go. All right, so here's our question 1. We already put this in the calculator, so that is what you do first. All right, and then A tells us we know that F is this table and G is that algebraic function, and H is a brand new function, and that's the composition of F of G of X. And they want us to find H of 4. So on your booklet, and remember your question is going to be on a computer, so you will not be able to write on the question. So just everything we're just going to write it in the booklet. And so you would write H of 4 is equal to G of F of 4. All right, and then where would you start? F of 4. And so F of 4 is going to come from the table. And so what is F of 4? 5. So you look when X is 4, the function is 5. And then G of 5 you can get from your calculator. Now, the wording on this is a little different than what it is here. It says something like, show the work that leads to your answer. The work that leads to your answer is probably just going to be you writing this out, G of F of 4. When you get F of 4, changing that to 5. G of 5 you can do in the calculator. And so if we put that into Y1, I would recommend that you just pull up Y1 and you put 5 there. You could also go to the table. Hold on, don't write this as the answer. It does tell you to give it as a decimal approximation. So I don't think they would give you credit for 11/5, which is super annoying. But 11/5 is 2.2. Now, if it's a decimal like that ends at 2, there's just 2.2 and you're done, don't worry about 3 decimal places. You don't have to put 0, 0. But if it kept going, you would need to be accurate to 3 decimal places. All right, y'all good? Okay, the next question is an inverse question, and it will be. And so we want to find F inverse of 10. So obviously, it's not F of 10. Now this question could be harder. They could, Brian Passwater could have had 10 something. He didn't, but it might be more challenging on your test. So F inverse of 10 is not the same as F of 10. You're trying to figure out what X value makes the function equal to 10. And so what is that? 5. And there's really no work to show there. I would just say F inverse of 10 equals 5. The next question is going to be either find when this function equals a number or find the zeros. So this one we want to know when G of X equals 4. So G is the Y equals 1. And so what do you think we should put for Y2? 4. All right, so it looks like we have 2 values where this function is equal to 4. And so we're just going to do second trace to calculate the intersection. And you just move close and then hit enter 3 times. All right, and this is super important that you're accurate to 3 decimal places. Any questions on that? Okay. And then the next question is going to be about end behavior. And this one, I picked a really difficult one for in behavior because when you just look at it, it looks like this one is going up in both directions, but this is a very small window. This is just negative 10 to 10. We can't see what's happening, the whole thing. So I can't remember. I'm going to try to zoom out and just see what happens. I'm not sure what this is going to look like. Oh, yeah, that's good. I wonder if you can take that away. All right, there we go. So now we have a better picture of what the graph is. We don't need that horizontal line. That's where 4. We're just looking at the function. And so we want to determine the in behavior as x decreases without bounds. So what side is that going to be? The left side. What is the function doing on the left side? Also decreasing without bound, going to negative infinity. Very good. So just be careful. You might not see the whole graph if you just look negative 10 to 10. So watch out for that. Now, in the last 2 years, I don't think there's been one that has happened, but just be prepared for that. Now, we do have to give our answer as a mathematical limit, and a limit has 4 parts. You have to have all 4 parts to get your point. So one part is lim. Another part is what x is doing. And so if x is decreasing without bound, x is approaching negative infinity. Right? And the third part is the function. Now there's 2 functions here. If you put f of x, you miss the problem. So this function is g of x. And then on the left side, we're going towards negative infinity. Now you only have to do one side of the in behavior, whatever they ask for. You can do both, but to get your point, both have to be right. So I would only do one. Just do the one they asked for. All right, and then part C on this one asks us to use the table of f to determine if f is best modeled by a linear, quadratic, or exponential or logarithmic function. So this is what I want you to do. I'm obviously not going to be in there with you, but after grading the test, people who did this usually showed as much work as they needed to, that possibly they left something out in their explanation and they would still get their point. What I want you to do is in part C, just recreate the table. It'll just take a minute. It doesn't have to be beautiful. And so if we are making this decision about linear, quadratic, exponential, and logarithmic, automatically I would look at the x's and I can tell that they are increasing by 1 each time. So I would do something like this. So if you write that, but then you don't write it out in words later, I just did a +1 on each of those, then you still might be okay. I want you to do both, but. Now if I'm looking at the f of x, it's obvious to me we're not multiplying. And so what we would want to do is find the first differences. And so we're just writing down how these f of x's are changing each time. All right, so those aren't constant. So then we would go to the second differences. And they are increasing by, or that is a constant too for the second differences. So what do you guys think? Yes. So you would say f is best modeled by a quadratic function. If you just put quadratic here, it'll be okay also. So if you're like running out of time and you just want to throw quadratic down, it's okay. But we're going to practice doing it perfectly. All right, and then 2 is where you give the reason. So we're going to give the reason based on the relationship between the change in output values of f and the change in input values of f. All right, so I'm going to start with output this time. So on this output, we would say the second difference is and output values are a constant 2. While the input values are increasing by 1 each time. All right, what questions do you guys have on FRQ 1? It's not too terrible.